Welcome. My name is Brian Hitt. On behalf of the Cleveland Auto Dealers Association, we are going to talk about Lockout Tagout. So what is Lockout Tagout? So I'm referring to something that is, again, we're talking about an energy source, right? We're talking about electricity, it could be gravity, pneumatic, hydraulic. All of these things are referred to as that energy source, and it really is a communication method. We are communicating to somebody that this particular equipment is locked out, tagged out, right? That you can actually service it or fix a piece of equipment, right? There are many different types of devices that we use. So we have locks, blocks, chains, multi-hasp, valve covers. We have all kinds of different things that we can use for doing lockout, tagout procedures. Again, if your dealership, if you're somebody who's working on your lift, right, you're going to see a what? A tag, you're going to see a lock, and you might see a hasp on the electrical and the pneumatic systems, right? So these are all different types of devices that are being used to actually do lockout. So this, you can see in the picture there, these are some of the tags that you would see. They have to be durable, they have to be standardized, they have to say, right, you have to be able to read them, and they have to be able to say, danger, do not use, do not operate, something along those lines. So again, as I mentioned to you, many different types of sources. Everybody thinks electricity. No, it can be a wide range of stuff. We see hydraulics, we see pneumatic. You typically don't see the rest of that. Gravity could be one though. Again, something is on a lift, right? Gravity is a source of energy. So some of the things we talk about as far as their electrical terminology, and just to kind of make sure people understand when I start talking about, and this certainly comes into play when we talk about as far as the hybrids are concerned, and as I was just mentioning about the hybrid. So what is current? Current is the movement of that electricity. Resistance, we talk about that. How much does it take to overcome or the opposition? Voltage is the force. How much force, how much pressure? So what are good conductors? Metals are good conductors. What are good insulators? Rubber, glass are good insulators. Again, typically people have fiberglass sticks or something like that. Rubber gloves, right? Rubber gloves that will protect you. And when I say something is grounded or grounding, we are talking about what? Electricity going to ground, the earth. So what happens with an electrical shock, and this is just important to keep in mind, it's the path, right? It's the amount of current, right? And that path. And if it goes through your heart, that's going to be a big time concern, right? Any type of electricity that's going through your heart, always a very big concern. And please do keep in mind though, if I say something is low voltage, and again, I already mentioned to you about that 50 volts, right? Does a 48 volt battery on a forklift, could that hurt somebody? Yes, it could. Again, just depending upon what the path is, what the current, but again, according to OSHA, to be a hazard, you have to have at least 50 volts. All right, so folks, so some of the things that we talk about here as far as lockout tagout procedures, and we'll kind of go through a number of these different procedures. We'll talk about some of the things, but there are two things that are very much a concern for somebody in the dealership. So those two items, hybrids and aftermarket remote starts. Now, these are not things that are being regulated by OSHA or any type of lockout tagout program, but we have some real concerns because of the energy, right, or the power. Now, aftermarket remote starts. Now, folks, there are a number of these out there, and yes, I am referring to aftermarket remote starts. These, unfortunately, are notoriously dangerous when people are working on these cars, right? And again, we're typically talking about the technicians. So when you're working as a technician on these cars, many times you are not aware of the fact that this car has an aftermarket remote start. Why aren't you aware of it? Because there's no label on it. There's no other documentation. You open up the hood, you don't see anything in there. And yes, unfortunately, we have seen injuries occur because the hood's already up, the car's on the lift, right? And the owner, the driver is in the waiting room, reaches into her purse, hits the remote, reaches into his pocket, hits the remote, and it starts up. And yes, the hood was up. So what happened? The switch wasn't put in. The hood switch was not installed on these aftermarket remote starts, right? A very, very bad thing. On an actual factory installed car, those things are always what? They're installed. They work, right? So when the hood's up, you're not going to have an issue. Okay, so that's one big concern. And then we talk about the hybrids. So hybrids, we are talking about electricity, voltage-wise, that can be as high as 600 volts of power. So folks, you won't find 600 volts in your building that you're working in. Yes, you will find it on a hybrid, 600 volts of power. So a couple things here. When we talk about electricity, why doesn't a 12-volt battery kill you? Well, because there's not enough voltage. In theory, right, according to OSHA, you actually have to have at least 50 volts of power, right, in order for it to drive that electricity through your body. And once we get more than 50 volts, then it's all about amperage, right? Amperage, or the quantity and how much electricity is actually going through your body. So a 12-volt battery doesn't have enough voltage, okay? And then we talk about, can electricity travel through the air? Absolutely. Lightning is a good example of this, right? So yes, right? Somebody could be working on that car, they could have their gloves on, they could have all that, proper equipment. You walk up to that technician, you get within 3 feet of somebody that's working on a battery that's 600 volts. Can that electricity travel through the air and electrocute you? Yes, it can happen. So those are some really big concerns we talk about. Again, hybrids, AC systems, DC systems, right? They have an electric motor, and again, they're constantly going back and forth. A DC motor does create a magnetic field. If you do have any of those type of defibrillators or any of those kinds of things in your chest, right, a magnetic field can have an impact on those concerns. So again, we talk about, most of the time you see what? 110 volts, right? That's typically what you see on the electrical power. There's how many amps? It could be a 15 amp. So keep in mind, that 110 volt circuit that's right over there on your wall, that circuit has 15 amps, and it takes milliamps of power across your chest to put it into something called fibrillation, where you have to do what? Defibrillate you, basically reshock your heart to get it to start up again, right? And folks, you should never receive a shock, right? That is, if you're getting shocked or something, that's bad. Never should you receive a shock. And there is that whole issue. Again, we're talking about milliamps of power on this next slide here. And look at the response, milliamps, right? You can actually feel that painful shock. You can have respiratory arrest up to 150 milliamps. And then certainly once you get into 1 to 4 amps, we talk about nerve damage, death is likely, right? And that's the type of current going through your body. So as I already mentioned to you, if you see a problem, you obviously want to make sure you report it, right? These are all things we talk about even with Lockout Tagout. Before you lock out, tag it out, somebody needs to make sure they are reporting any kind of a problem, right? The process, the procedure. We always talk about lockout, tagout, tryout, right? You got to make sure that you actually are doing what? Testing it or trying it to make sure that maybe the circuit wasn't the right number. Maybe I had the wrong circuit breaker, right? So you have to make sure that we're following whatever procedure it is and going to that correct panel, to the correct breaker, whatever it is, and then trying it out, right? Make sure, or testing it, and make sure that if, again, testing, you might use electrical sensor or something like that. So some safe work practices, again, folks, only qualified people should be working on electricity, right? You don't want to be wearing conductive apparel. These are all things we talk about as far as some safe work practices when it comes to working with electricity or doing lockout tagout programs. This concludes the presentation of this particular module. Thank you very much for your attention and your participation, and please follow the instructions on the next slide.